This is video 621, and the goal of this is to kind of summarize the law of cosines and to look at an implication involving bearings of ships and such. So first of all, the law of cosines. The law of cosines is, I like to think of it as a twist on Pythagorean theorem, because you are basically you're looking at what, sorry, my pens won't let me pick here. We're looking at we have the Pythagorean theorem that kind of pops up here. A squared equals b squared plus c squared. But of course, this is not a right triangle. It's a triangle where we know two of the sides and we're at an angle. So we know BC and A, angle A, and we're looking for side A. Okay? Or it may be the case where we actually know all of the sides and we're looking for the angle. So these cases will be, that's kind of what the cases where we'll use this with. Now, what's most important is that you realize that you have to have side angle side in order to use this formula. And by side angle side, you have to have side angle side. So we have side angle side. And if we have these two sides and this angle A, we can find the missing side A. The other case where we can use this, not just side angle side, but is side, side, side. So that's a case where I know all three sides. So I know A, B, and C, the sides, and I can find one of the missing angles using any of these three formulas. So let's take a look at how you can get this formula memorized. It's not impossible, but let's take a look at how we're going to do that. So we're solving the triangle shown with angle A, 60 degrees, sides B, 20, and sides C, 30. So how do I get this formula memorized? Well, I remember that it's a squared equals b squared plus c squared. And then you got to take off and adjust for the fact that this is not a right triangle. So minus 2bc, so we reuse these two sides. And then, of course, law of cosine, so cosine of angle A, because these two always have to match up. So in this case, I have angle A is here, so that's going to be 60 degrees, so cosine of 60. And then I have sides B and C. So sides B is 20 squared plus 30 squared minus 2 times 20 times 30. Notice how you could interchange the 20 and 30 and still get the same results because they have the exact same impact on the formula. So it doesn't matter which one's which. So I know they were labeled A, B, and C here, but if they were labeled X, Y, and Z, it wouldn't matter which one's which, as long as you know which angle you have and which side you're looking for. Now I'm literally going to punch this into my calculator right now in order to find the value. So punching that into my calculator will give me the exact value instantly of this side A squared. In doing so, I get a nice, easy answer. This whole value gives me 700. I make sure that I'm in radian, not in radian mode, but in degree. And then the one common mistake is that we will forget to square root at the end, because this is not A, this is just A squared. So to get A, I need to take the square root of that answer, and I get 26.46. Now, if I want the exact answer is the square root of 700, and if we simplify that using what we know about square roots, we see it's 100 times 7. Therefore, it's 10 squared root of 7 is the exact answer, and the decimal answer is 26.46. So the law of cosines actually can be fairly easy because you are working with a very simple formula that's not as much to think about with the ambiguous case like we have for law of sines. But there is a formula to memorize and to be able to use. Let's try the next one. So now we're solving triangle ABC if we know all three sides. And to solve a triangle, we haven't talked much about this, but solving a triangle really means finding all the angles and sides. Now notice in this triangle, A, B, C, I'm given the three sides because it's lowercase a. So lowercase a is across from angle A, so that's going to be 6. Across from angle B is 9, and across from angle C is 4. So I have the three sides of this triangle, and now remember I can use law of cosines when I have the three sides. It's going to be any of the three formulas, so I'm just going to do the first one. It doesn't really matter. Oh, sorry, b squared plus c squared minus 2bc cosine of angle A, because of course side A has to be equal to angle A. It will give me angle A. Now I'm going to plug in all of the sides in this case. I'm looking for the angle. I don't know angle A. I'm looking for angle A. So I'm going to punch in 6 squared equals 9 squared plus 4 squared. So again, the 9 and 4 are interchangeable, but the 6 is not because I'm looking for angle A. Minus 2 times 9 times 4 cosine of A. So I'll work this out. 36 equals 81 plus 16 minus 72 cosine of A. Now be really careful here. Follow your order of operations. I can add these two together, but I cannot subtract this because it's multiplying with the cosine of A. So it's just going to copy down. And I'm going to add those two together, and 97 equals 36. Now I'm going to solve for cosine of A, so I'm going to get rid of the 97 from both sides. And I'm going to be left with negative 61 equals negative 72 cosine of A. My next step would be dividing both sides by negative 72 to cancel that out. I'll get cosine of A equals 61 over 72. Of course, the negatives will cancel. Now I'm at the point where I'm looking for the angle, so I'm going to take the cosine inverse of both sides because I'm asking what angle is it that has this cosine. And so plugging that into my calculator, the angle whose cosine is 61 divided by 72 will give me 32.089 degrees. So A is 32.089 degrees. So now I have angle A. Now the more exact I write it, by writing 3 decimals, I'll be able to find the other angles a little bit more efficiently. But now I have angle A, 32 degrees about. Now what I'm going to do is I'm going to revert back to a simpler formula, the law of sines, to find the other two angles, or at least one of the other two angles. So by law of sines, I'm going to use this angle on this side, so sine of 32.089. Just to be a little bit more exact, over 6 equals, so that's going to equal the sine of, well, it doesn't matter, B or C, whatever one. So let's just go with B, we'll go in order here. The sine of B over 9. And now I'm going to solve for this missing angle. So 9 times the sine of 32.089, and then divided by 6 to get the sine of B equal to 0.796. So I have the sine of B equals 0.796. Now I'm going to ask my calculator who has that sine. And I get 52. I get B equals 52.83. Now I want to be careful here. There may be more than one right answer because of the fact that I'm using law of sines and I'm finding a missing angle. However, I'm finding a missing angle, this is the ambiguous case side-side angle, and I want to be really careful. 52.83, just like we talked in class, the other potential angle is 180 minus that because it's the angle on the other side of the unit circle. And I get 127.13, 17, excuse me. Now that angle might actually be B instead of 52.83. So what I'm going to do here is kind of branch off into two potential answers. So one answer is that angle B is 52.83. And the other answer is that angle B is 127.17. Now I can't simply say here that there are two triangles that might exist here because there is literally only one. I have the 3 sides. So how am I going to know which one's right? Well, I'm going to pick one of them and I'm going to solve for angle C using a similar strategy. I'm going to solve for angle C using a strategy of the law of sines again, and I'm going to see which answer makes sense. Because yes, there are two potential triangles that have these 2 sides and this angle. There are 2 potential triangles. That's what this ambiguous case says. Now the question is, which triangle am I working with? Which triangle also has a side of 4, as we see in this picture here, because that's the one thing that we know about this triangle. So now I'm going to solve for law of sines in 2 ways. So I'm going to kind of clean this up so I have some space to work here. I'm going to solve for that missing angle. So if I, very simply, to find angle C at this point, I'm simply going to do 180 minus 52.83 and minus the 32.089. And I'm going to do that for both of them. So I'm going to copy this exact thing, and I'm going to do it again on the other side, but now I'm going to subtract 127.17 and 32.089. The 32.089 I know for sure is angle A because I use law of cosines. Now when I do that on both sides here, 180 minus 52.83 and 32.089, I get 95.081. When I do that on the right, I get 20.741. So the question is, which answer is right? Well, look at this 95. This is the largest angle, according to comparatively, between these 3 angles that would make up this triangle. Is C the largest angle? Of course not, because 4 is the shortest side. So this is the wrong solution. The correct solution is here, 20.741. So the correct solution for angles A, B, and C are, this is angle A, this is angle B, and this is angle C. Because it fits with who's the largest and who's the smallest. Now, we'll talk more in class about some strategies to make that a little bit quicker in the long run, but hopefully that gave you another case of the ambiguous case and how we'll use that, and we'll have to think through that when we're solving for missing angles. It's usually when you're solving for missing angles. Let's take a look at a unique application question. We have 2 airplanes leaving an airport at the same time on different one-ways. One flies at a bearing of north 66 degrees west at 325 miles per hour. The other leaves a bearing of south 26 degrees west at 300 miles per hour. How far apart will the airplanes be after 2 hours? So we're going to sketch a picture. And we need to know our north, south, east, and west. This is north, south, east, and west. So you have to know which way is which. Now, we're going to draw a picture of the first airplane. North, 66 degrees west at 325 miles per hour. Now remember, they're going for 2 hours. Okay, that's another thing that we're going to use. So what that means is here's my airport, and we're taking off north, and then we're swinging 66 degrees towards the west. So this is actually the 66 degrees right here. So you always just follow it. You go north, and then you swing 66 degrees west. So this is my airplane number 1. And it's going 325 miles per hour. So this leg right here, this is how far it's gone, it's going to be 650 miles because, well, it's gone for 2 hours at 325 miles per hour. So this is 650, that length. And that's where airplane A1 is, right at the end of those 2 hours. Now we're going to make a similar sketch for airplane number 2. So now we start going south, and then we swing towards the west again, 26 degrees towards the west. So we're going to swing this way, only 26 degrees. This airplane's only going 300 miles per hour, again times 2 because it's 2 hours, so it'll have 600 miles, will be this leg right here, at the end of that 2 hours. And the question says, how far apart will the airplanes be? So we're really looking for how far from here to here. This is our x. So I'm going to kind of delete some of this so I can see better. This is our x. So we have this triangle, 650, 600. We're looking for x. And what we do also know is some information about the angles. We actually can find this angle right here using what we know about 180 degrees. This whole thing is 180 degrees, but I have to take off the 66 and the 26. So 180, remove 66, and remove 26. So I'm going to end up with 88 degrees left over. So this angle is 88 degrees. Okay, so again, all I did was use this 180 degrees, and I took off this section, and I took off this section, and found that what remained was 88 degrees in the center here. So I have this triangle, and it's side angle side. Now I'm going to use the law of cosines. So the law of cosines will relate the side x squared with the other two sides and its angle across from it, the 88 degrees. So 600 squared, 650 squared minus 2 times 600, 650, and the cosine of 88 degrees. Punching that into my calculator will give me the exact answer for x squared. And for x squared, I get 755,278.3926. Since I'm using this is a application question, I typically will get a decimal answer in the end. So I'm going to take the square root of that answer, and I'm going to get x equals 869. And that's, of course, in miles. So there's my solution. So the tricky part, I know, is drawing the picture. And then after that, you kind of just look at where you're at and figure out what you know about the angles and go from there. So we'll be practicing that a lot in class. Here are your checkpoint questions for your video. Do your best to find the exact answers and set up the problems and bring those questions into class. And we will talk about them then. Good luck and thanks for watching.